Please welcome your panel, starting with our fantastic moderator, Mr. Ian Zhu, Managing Director of NIO Capital. Welcome to the stage. Arfa Karani, Investment Manager at Klima Energy Transition. Welcome. Mr. Will Tope, CEO, LiNa Energy. Please welcome. Michael Cronley, CEO of Ascend Elements. Welcome. And Casper Peeters, the CEO of E-magy. Welcome to our panel. The future of solid-state batteries, ladies and gentlemen.
Good afternoon. Good afternoon. It's so exciting to be here in a beautiful city, Bilbao, to talk about the really advanced development in the battery space. I will start with the introduction of myself, and then I'll ask my panelists to introduce themselves. I'm Ian Zhu, Managing Partner of NIO Capital. We're new to the conference, so I'll give you some background. We are a venture and growth investor. Now we have about $2 billion AUM, investing in disruptive technologies which are transforming the automotive, energy, logistic, and these very large but very traditional industries. We do invest in China, but we also invest globally. I think during the last panel, there was some conversation about China. I feel like every time when I come to the West, there's fear. There's fear about China. There's some misunderstanding about China. But I want to say that if a company can leverage what China can provide, it can really help the company to develop in a much faster pace, tremendous capital efficiency, also have tremendous access to talent, which we would like to help if we invest into the company. And in terms of today's topic, we actually invested in CATL before it became a public company in China, have really witnessed how this little company 12 years ago and then developed into a global giant, now own about 40% global market share in the battery space. But also working closely with the battery suppliers in China, we understand after they become giants, the speed of innovation also slows down, even though it's a very competitive market. But given that they have a lot of infrastructure already built out and investment into the traditional space, to really develop, for example, solid-state battery, which is requiring upgrade in the infrastructure as well, I think it leaves a lot of opportunities for startups to play. I will stop there, and then I will ask my panelists to introduce themselves, and then we'll get into the topics of the solid-state development. Let's go with this sequence, please.
Yeah,
Arfa.
so I am Arfa, doing investments in late-stage startups. The fund is headquartered in Spain. Offices are typically in Madrid, so we don't get to see the best part of Spain as Bilbao. So it's nice to be here. Hopefully we'll meet at some point. So as a background, I've been a physicist studying solar cells during my PhD. That's how I figured what electrodes were and have a deep connection with device designs of all kinds. And have looked at all your companies as an investor. Previously, I was at a corporate venture capital fund doing investments and setting up our investment thesis on energy storage. And now I'm at an independent financial investor fund, and we are trying to support technology companies grow into large-scale commercial companies, batteries being a key part of it, and very much would like to ask you some more questions, Ian, on the panel about how do we actually take our European startups to China to manufacture at scale.
Sure.
So hopefully it'll be a fun panel.
Thank you.
But nice to see you all.
So I'm Will Tope. I'm the CEO at a company called LiNa Energy, and we make solid-state sodium batteries, and we do that using solid-state technology from the fuel cell industry and applying it to an old chemistry, originally known as the Zebra or the Durathon chemistry people might know. I think what's unique about us in the solid state territory is our approach is we're doing this because we get good enough performance out of really, really low cost raw materials. And we think that's important because then you can make longer durations of storage economic for solar. And we see this impending wave as solar and solar deployments grow so rapidly. People need to find a way to shift that out of the duck curve and make these projects of the future profitable. And we think we can be one of those technologies to enable that.
Yeah. Thanks. My name is Michael Cronley, and I'm the CEO of Ascend Elements. Ascend Elements is based in Westboro, Massachusetts, so we're in the U.S. We are a producer of cathode materials, and what makes us unique is we make our materials out of other people's scrap. So we take spent batteries, end-of-life batteries, manufacturing scrap, and we convert that into a very high-value material. So it's unlike other recycling companies that just collect batteries and transform them into a commodity or maybe resource recovery. Where we excel and where our technology is applied is when we convert this trash into treasure. Yeah. And so that's the unique value we bring. Now, why is a cathode company on a lithium ion or a panel such as this for solid state? My previous role, and I've been in the battery industry for going on almost 15 years now, I was the head of corporate strategy at a battery manufacturer, A123 Systems. And back in 2017, had the opportunity to invest in a couple of different solid-state battery companies. One was a sulfide-based, another was a polymer-based, and that was early on in a lot of the development. But there's a need for it somewhere in the value chain, and just how is it going to develop, and what does the market actually need? So I can contribute a little bit there, but also I've got thoughts on China and how China can help the rest of the world.
Yeah.
So.
Sure. Okay. Hello, my name is Casper Peeters. I'm the CEO of E-magy. E-magy is an advanced materials company, and we specialize on the anode side. So my neighbor here is focused on the cathode side. We make an anode material, and not much focus has been there, like worldwide. That anodes are typically made of graphite for 30 years already. And what we propose is to transition to silicon completely. And that is exactly the product that we make. And with silicon, you can create batteries with a much higher energy density. Combine that with the fact that due to that higher energy density, you need less material, meaning also less material to produce, so a lower carbon footprint of your battery. And silicon can be produced and sourced locally, so actually everywhere in the world. And this is important. In Europe, there's this Critical Raw Materials Act, which means that we want to become less dependent on other parts of the world for our raw materials. And silicon is sourced in Norway, Germany, Spain, France. And that is another benefit of transitioning to silicon. Okay, great. So we have a very distinguished panel with people from investment background, innovators, and companies developing different part of the value chain of battery making. I will start with asking you the question to bring us to the current stage of solid state battery development, and what's the exciting characteristic of solid state batteries which are contributing and which are needed by their customer. Just from kind of your part of the business, what do you see as the most exciting forefront of the solid state industry development? I'll ask Will to go last because the promise you said earlier was very exciting, but I will ask you to go last. Who want to go first?
So I can jump in first. So there was, I'll say, a lot of excitement back in the 2017 timeframe or several years ago. Solid state, and why was solid state important? Really, there was a drive for higher energy densities. Mm-hmm. And why did we want higher energy densities? It was ultimately to lower cost. So if we went with a really high energy density anode material such as a silicon or a lithium metal, that was going to be great. And the idea or the hope at that point in time was We're going to be able to get the energy density up. We will eventually figure out how to make these things at a lower cost, and therefore it will have wide-scale adoption. Well, fast forward now 7 years or so, there's still a lot of fundamental science that needs to be done with some of the technologies that are out there. And we haven't really advanced. It seems like solid state has been 2 to 3 or 5 years away from production for the last 7 or 8 years. So it hasn't really advanced that much. And as a result, one of the major things that has happened, it's not making the advancements it needs to necessarily in cost with a lot of the, call it traditional solid state battery companies. And so they've struggled to launch as they're figuring out their technology. So I think a lot of people are still waiting for the technology to develop, but ultimately they're developing this technology in an environment where the rest of the lithium-ion battery industry has been driving down cost.
Yeah.
Because when you step back and you look at the market, what the market is needing is it needs lower cost batteries. And so all of the materials, all of the innovation has got to go into how do we drive down dollar per kilowatt hour.
Yep.
And so, when I look at, the typical solid state battery companies, that's while they're still struggling with some of the fundamental science, the rest of the industry is advancing. And, we've gotten to a point now where, we're seeing very low dollar per kilowatt hour, and we're seeing very wide scale adoption of batteries in the transportation industry, the renewables industry. So, it's becoming challenging.
Right. Okay. Michael have alluded to the challenges of solid state adoption, but we'll talk about that later. Casper, you want to talk about from your field what's exciting?
Yeah, what's exciting is exactly that energy density. So for several applications, and especially the mobile applications, electric vehicles, and also phones, laptops, drones, wearables, you need higher gravimetric energy density. So that's the energy per kilowatt, the energy per kilogram. The challenge may be that the energy per volume, per liter, is a little bit lower, so that's the challenge. But the higher energy density is really what many applications require, and that's why it's a promising technology.
Yeah. Arfa, from your investment,
Yeah, for
what do you
me
see?
it's, or at least ever since I got to know solid-state batteries, it's been very straightforward. It's been 3 key things. One, energy density, of course, but not energy density in a sense that just a little bit more than what we can achieve with existing technology. Energy density in the sense that doubling or tripling the energy density of the lowest end of what we can now achieve with the existing lithium-ion batteries. So really enhancing. And in that regard, the timeline is not really an issue, right? For me, it's always been, it's going to be higher, significantly higher energy density than what we have, but it can take time. Second thing has been safety. There is still, especially in stationary storage or areas where you don't think batteries are, you can't put them indoors without much security, safety, insurance, coverage, et cetera, So I think safety aspect of solid-state batteries is another important factor that really excites me. And finally, it's the second life use. So after having been in an electric vehicle for 10 or so years, a solid-state battery, or at least that's my hope with the technology and the promise. I'm sure will tell us more about that. But the idea is that at 80% state of health or so, how can we trust these batteries to still be safe to run in second life applications, just to give them a bit more longevity, right? Before we start to think about taking materials out of it and trying to recycle it. So those are the key things for me.
So later I'll ask you guys, where do you see the application scenario would go first for solid-state battery based on traditional lithium technology? But Will, you have a different approach. I'll ask you to explain.
You also asked, what do the customers want?
Yep.
And perhaps controversially, what the customers definitely don't want is a pipe dream from a solid-state battery company. I think it's really quite simple. What customers want, and certainly in my experience, is they want something to do what lithium-ion can't. Because as we've talked about, the moving behemoth, which is LFP, is an incredible battery technology. And it's not about necessarily coming in the side with a energy density gain, because the rate of cost decline on standard lithium-ion technology is astronomical, right? So you may as well just stay the course on the bankable tech. But maybe 80% of the market, a rapidly growing market, but where we've seen success, if you have customers that cannot use that technology and have one thing that really limits their ability as a business. So if I think about probably one of our more important commercial relationships, a large strategic in India, their issue is that they're deploying a lot of solar. They need to fortify that solar, and they're putting solar down on locations that are -20 at night sometimes and +40 in the day, right? Yeah. And traditional technologies really struggle in that, and so they want a solution. And if you can do one or two things really, really well, this market is growing so big that it's going to get segmented, and those, you don't have to take on the LFP behemoth to make a really successful business here, I don't think.
Right, so you're taking a different approach. Why don't you explain a little bit more in detail the approach you're taking and the promise you're offering?
So it really is that. It's taking, we talk about cycle life. So we started with a proven chemistry. That helps a lot, right? Because ultimately this needs to get to the point of bankability, and to do that you need to be able to be really sure you've got a stable chemistry and you know what happens on year 5, you know what happens on year 10. And again, if we go back to why we took a bankable chemistry that was really great, and then we said, we know how to do things with solid oxide ceramics specifically, straight out of the fuel cell industry, that could make that original chemistry much cheaper. And we said, okay, that combination of things is getting a lot out of a really low-cost bill of materials, and happens to work really well even if it's 40 degrees C outside, because it's a high-temperature battery. Yeah. So you took all these things together and you said, okay, where's the market at? Again, I'm not necessarily going to come in and try and sell dreams and claim that I can grow like cattle, right? But I do know there are really important pockets of solar growth that can't use their solar because we're hitting deeper and deeper duct curves, but will continue to deploy solar. So it's a given now that they're going to continue to deploy solar, but it's going to be coming with longer durations of storage. And today they can't use lithium-ion for a combination of the technical reasons that I mentioned. It struggles in temperatures, in wide flexibilities of temperatures. But the other is, well, it's still, as cheap as it's got, it's still too cheap to deploy for 6 hours on its own merits, right? And so then that's something really magic. We think we can step into the space and solve the customer's needs, and we're at a stage now, just to contextualize, we're at a stage now where we're piloting our technology. So in India, just started in the Middle East. There's a lot of solar coming, and something needs to fortify it.
Yeah, you're not just addressing the short duration energy storage, but also going after
not at all. Yeah, so I would say if you're building a 2-hour ESS today, I would order an LFP one from Capital.
Yeah,
right.
So you're going after the longer duration.
So exactly, yeah. And because if you try to design a battery to do everything, it's pretty difficult, right? And all solid state batteries tend to start with, this is 10 C, 1,000 watt-hours per kilogram, 1 million cycles in this God battery. And then as we've seen it move out the lab towards commercialization, you're going to have to take your choices on what's most important, and that will be customer-led. And so we've taken design choices right down to the cell level to say, I don't need to do 1 hour, 2-hour discharges. I'd rather make a cheaper battery that can't do that, but can perform for 4 to 8 hours.
Which is an interesting application area for solid state, which is not the typical space that solid state is going after.
But you get the, I'll be very careful, I'm starting to sound like I'm pitching. You can tell I'm at an investor conference, right? But there is some universally useful features of solid state battery technologies that I think everyone benefits from, which is the safety, for example, right? That is really good. I think you can't hang your hat on it as the thing you do, because there are a lot of safe battery technologies coming through the pipeline, but there are the periphery benefits that just make it a really good approach to building a battery.
Yeah, okay. Casper, switching to you, you're making anode for the battery space, and you're at the mercy of the battery cell makers to adopt your technology, right? So you have to convince them. Even with great technology, the cycle can be long. What are the things that you do to try to shorten that cycle, or try to convince, the cell makers to use your technology?
Yes, that's the challenge of bringing a new technology to the market, and you don't own the whole market or the application, so you have to work together, and that's exactly what we do, obviously. And I must admit, we made some changes there as well. So we are a material supplier, and as a material supplier, you tend to think, okay, we have our material in a bottle, and it's a powder in our case. And you ship the powder to the customer, and then you keep your fingers crossed. And you learn quickly that that is not the way to develop a business, to develop a relation with a battery company. Battery is a complex system, as well, most people here know. It's really complex to make a battery. It really several components working together. So what we do is not only sharing the knowledge that we built in the company with the customer, but also we make batteries. Although it's not our business model. Our business model is to supply silicon as a powder, but we do make batteries to demonstrate and to find the best performance and to work really well together with the customer and to demonstrate that this is what you can reach with this technology. Yeah. So we have to go one step further than you typically would do as a material supplier.
Yeah, maybe just to add to that from an investor perspective, right? It's all cool technologies and we see so many of them in the market. Yeah. But I suspect everyone struggles, as Casper is mentioning, because you're never, if you're an anode or cathode material company, you're struggling to find partners that you can commercialize it with. Yeah. And the cell manufacturers have sort of dedicated their production for years to one particular product and one particular technology. Right. And there's not much room for them to change or to switch. The qualification process can take 2 or 3 years minimum, if you're lucky. And as Casper was saying, you sort of have to build beyond just the material innovation. You have to build cell manufacturing expertise within the company as well, unless you find a partner that can do that for you. So we are putting sort of a lot of stress on just innovation companies that are trying to make innovations in parts of the battery. Yeah. And solid state is one good example of that. But from an investor perspective, that's sort of where we get stuck, right? That's where we get stuck in terms of, okay, so it's a great technology. You've proven that your cycles are X many and you can stand certain temperatures. You're targeting a market that exists and it's large enough and there are no other technologies that can possibly serve that market or that energy density or that cycle life or that charge rate, you name it. But how do we commercialize it? Right. Right, and that's where, from an investor perspective, this is just really touching the nerve, right? Because we really see good technologies that we want to support, but it feels like financially it just doesn't look feasible. Yeah, I remember when I look at a lot of the business plans in the battery space in the Western world, very typically it's licensing technology instead of manufacturing, right? And for one, I think the talent or the ability to manufacture is very hard to build. And second is maybe it's easier way out, right, to commercialize. But I feel like that kind of model is leaving a lot of chips on the table. Also potentially not very beneficial for developing the technology and helping it go to market. You may need to go to the actual mile to build a prototype, to build more proof for your technology in order for customers to adopt the technology. How about in the cathode space? In your space, do you need to convince customers? Yeah, so I think there's always a go-to-market strategy, but if you're going to be a new company and you're going to enter into the space offering, you have to do something different. You have to disrupt one way or another. And in our case, we make cathode materials a completely different way. So they perform just as well as cathode materials made from virgin sources, from mined ores. We make our cathode materials. It isn't a very technical engineered material, but we make it from a very low-cost source of feedstock. And so that's the unique innovation we're bringing. Of course, along with that, it's a much lower CO2 footprint. It's far more sustainable. And really, one of the problems we haven't hit yet, but we will in the future, is once we produce all these batteries, what are we going to do with them? And so it's not too difficult to think in the future, we're going to have to
recover and reuse all of these sources of material that go into batteries.
Yep.
So, in a couple of decades, more than half of all battery materials will come from a recycled source. So you have to have a technology, you have to have a supply chain that's developed that is going to be able to utilize these resources and this being able to recycle the batteries, reuse them, and put them back into the battery supply chain is something that's critical. Almost every battery manufacturer, and certainly every OEM, knows this. Whether it's legislated or not, it's an economic reality. We have to reuse these materials, and there's a lot of better ESG benefits to it by reusing materials. So. Yeah. So certainly, so that's where we're bringing, that's our disruptor, that's our innovation that we're bringing to the market. A battery maker or an OEM can go out and buy cathode material today, and it works just fine. Yeah. But what's different about it? That's the innovation that we're bringing.
Yeah. Well, can you share kind of what's the range of the recycling ratio of the material?
So it depends on what we're bringing in. So what we specialize in is we specialize in NMC cathode materials. So it's a mixture of nickel, manganese, and cobalt. We bring those batteries in and we begin to recycle them. If it is a 10-year-old battery, and say it's made out of an NMC 111, and we're upcycling that effectively to making a high nickel cathode material, say a 90+% nickel, which is what the market wants today in an NMC cathode. You're going to have to actually add a lot of nickel and or dilute the amount of manganese or cobalt in there. So there's a rebalancing. So in that example, you're down around 20-30% recycled content. You have to add or change the ratio of these metals. Now, if you're recycling something that looks a lot like the output material, so in the case of battery manufacturing scrap, you're making a battery that is called an NMC 955. It has 90% nickel in it. You bring it in, you begin to process it, recycle that, and you deliver the same cathode material, and you deliver it right back to that same battery manufacturer. It's virtually 100% recycled. Yep. So it just depends what you're bringing in and what we're shipping out.
Okay, yeah, you have some point to add?
I was going to say, I'm glad it hits a nerve from an investor perspective, because it is the nerve when it comes on to the startup side, getting to the point where you've got a customer willing to take risk on a new product, right? Yeah. I think a lot of people underestimate that, especially at low TRLs. It's that build and they will come mentality. It's like, well, just look at my results. There's a big gap between showing some cell data and finding someone willing to pay you to use your technology, right? Yeah. And it is all, especially when you have something off the shelf warranted for 10 years and 6,000 cycles, right? But to bridge that gap, I think it comes down to one, product market fit. Again, right? It's easier to find a partner to trial your technology if they can't use that thing off the shelf, right? Yeah. So it's pretty key to get a really motivated partner who really wants something new, who's really stuck. And then I think it's appreciating it's going to be a long journey, right? So the things, if I think about, there was a lot of heartache and hard work between building battery cells and then delivering a system worth of them in Mumbai. And a lot of that is from early days, you have to be pretty transparent, right? I don't think this industry is transparent enough about what data actually means. People will go cherry pick one KPI and say, hey, look, I've solved it. I've got a 400 watt-hours per kilogram battery, but if it cycles 2 times, who cares? Sharing the full suite of data, explaining it to the customer, say, this is where we are now, this is where we're going, what does it take for us to get there? And they're probably not going to care the first time you tell them, or they might care, but they're not going to act, the first time. 6 months later, you share where you've got to, oh wow, you actually managed to do that thing. And then that leads on to having a conversation, doing some open source techno-economic analysis to say, okay, well, let's try to get on the same page about how cheap we can make these batteries, right? And what do you think? How are you going to use them? And then eventually they're going to be like, oh, wow, I'm starting to trust these people. Yep. Let's do some independent cell testing. Send me some cells. I'll pay for some cells. And you're like, oh, this is getting good. And then, for us, then we got a pilot project with a large reputable brand, switched it on. And then it's this virtuous circle, right? Because at that point, you pass the very raw first of its kind, and everyone else is like, oh, wait, you got a system with that person? Like, can I get one?
Yeah.
And it spirals. And, going through that journey, it's incredible. Parallel to that is manufacturing, though, right? And that is even tougher. To like you say, anyone thinking they've got a technology that's interesting enough in a lab, a battery technology, that they can go license it, I do not believe that for a second that anyone's actually going to license something at that early stage these days.
Right.
I think you need to be ready for a long journey to 100 megawatt hours before someone's going to license something.
Sure. Well, thanks for sharing that. I think the go-to-market definitely take perseverance and then openness, right, to share data with your customer to gain that trust. I remember when we, one of our portfolio, not in the battery space, in autonomous driving, have to open their source code in order for customers, OEMs, to use their software to build that kind of trust, which in a way is not bad. Otherwise, you can't even get into the door. And then you own the technology, you can continue to improve and become really the software of choice. It really takes to the level of that kind of openness in order to gain the trust of the customer. On the manufacturing part, so you already started talking about manufacturing. I mean, we invest in technology company which has tremendous promise in science, but bringing that to really the end product, there are many steps to take, right? Manufacturing is a key step for it. When you think about manufacturing, what are the things that you need to build into your business in order to scale up that business? Do you need to go international? Do you have the right facility, local, talents that you can find? Maybe I'll ask the panelists to share really on the scaling up part. What are the things you need to consider and what are the challenges you face?
Okay. Well, first of all, it's true. I mean, it's already difficult to bring a real product to the market to find product market fit, and then you reach that, and that's only the beginning. And then you have to be able to make it at scale and at the right cost level. Yeah. So it's totally true, and that holds for actually, well, for solid state batteries, but also for any other deep tech product that you bring to the market actually. So producing at scale is the name of the game, and there are several steps to make. In our case, we talk about kilograms output or tons output, and it's really a step from, well, you're very happy that you make the first 10 kilograms of material, and then you can prove that it works, but then you have to go to 1,000 kilograms, which sounds like a lot, but it's only 1 ton. Yeah. And then you go to, well, then you prepare for 25 tons, 300 tons. It are huge and important steps, and in our case there's lots of engineering involved. We have a proprietary process, so it's not that we source equipment from other parties off the shelf, but we have our proprietary process with our own equipment, which I think in the long run is key and critical to our success, but in the short term it means that we need to focus on that, and we just have to do that.
Let me maybe drill down, specifically in terms of location. Do you feel like you can build a manufacturing business in Netherlands, or would you explore other part of Europe or Asia, or, just from a geographic perspective, is it realistic to build an annual production in Europe?
Yeah, in our case, we will be looking at other sites and other regions, certainly. Having a pilot site in the Netherlands is totally realistic. That is not a problem at all. And what is important, so I mentioned we do silicon. Our product is based on silicon. Unlike many other silicon companies who start with silane, so that's silicon in a gas form, that is way more difficult, even dangerous, and thus costly to transport. So when you use silane as a feedstock material, then you're really stuck to places in the world, a few places in the world where you can source that. In our case, we use silicon metal. It is widely available. So that makes a big difference in terms of feedstock and sourcing. Yeah. Now I understand the second element, of course, is labor and the cost of labor. And we'll be looking into that in our next step. First we do our pilot line, our second-gen line, and then we might go to other places of the world based on labor, cost of labor, and of course energy mix.
Yeah. Michael, you're building manufacturing capability in North America?
Yes, so we've gone down the path of not licensing, but manufacturing. Yeah. And it's a little bit of, I guess, some of my background. Been in much larger manufacturing companies. This is my first, I guess, smaller startup. But I'm used to manufacturing, used to making things. And I believe, like you were saying, there's a lot of value in manufacturing. Sure. So there's value in the technology, absolutely, but just as you were saying, well, you have to, a lot of companies that want to license, you have to prove the technology. And the best way to prove it is to manufacture it at scale. And you can also prove the economics of it. So right now at Ascend Elements, we are building about $1 billion facility in Kentucky in the US to make cathode precursors out of spent lithium-ion batteries. We do have that launch partner. They've given us just what you were describing. We're working with them back and forth. It does take co-development of these materials so that it works in a battery, because it is a very complex system. So we have that launch partner. We're building this facility now, and even though we're a new company, we have staffed it with people that are from a lot of large industrial companies, chemical companies, PCAM companies, from across the globe. And we're doing it in North America. You know, is it the best place in the world to make PCAM? Well, most of it is actually made in China. They're the world's leader in it, but there is a need to have it and make it locally, not only because of legislation, but also it's a highly incentivized industry, at least in the U.S. Sure. It's turning into that way in Europe. Yeah. And so having the ability to manufacture battery materials, even batteries, EVs, globally, you're going to see more and more global companies doing it. So we're headquartered in the U.S., we're starting in the U.S., but just yesterday we announced our first joint venture in a plant in Europe. So we'll be starting in Poland, and we're going to continue on in Poland, and then we'll see what's next after that.
Okay, I want to drill down to that question because it's very interesting. With the Inflation Reduction Act, the U.S. is really trying to build a battery supply chain and also for renewable. We look at setting up factories in the U.S. It just takes 3 times longer than setting up a factory in China. You got to deal with all this kind of approval process and all that. And once you build the factory, the operational part of it is also very expensive. With the labor costs much higher and all that. Is it realistic to build a battery industry in the US? And given the policy direction, I think there will be some manufacturing capability. If it's built, and how much cost increase that will have to undertake compared to the Asian manufacturers?
Yeah, so certainly Asia, in particular China, has a huge lead over the rest of the world. That's undeniable. But when you look at the battery material space, even battery assembly, it's largely automated. So it takes out the cost of labor to a certain extent. But I will actually absolutely agree with you that China is able to build factories faster, less expensive than really anywhere else in the world. That's why having helpful legislation, if, for example, the United States wants to have a domestic battery industry, the government has recognized they have to help it. And so that's what they've done. So that helps offset some of the cost. And it is more expensive to build a plant in the United States. So if governments are willing to step in, and it looks like they are, they're doing the same thing in Europe, that solves that problem. There's the speed. In the US, we're not as fast as China, but we are fairly fast. That's one problem Europe has. There's just the permitting and regulations, and we're dealing with it now. It's problematic. And so as much as Europe really wants to have a domestic battery industry, the permitting process is just so cumbersome, and it takes much, much longer than in the United States.
Right. Okay. Well, what's your experience, or what's your plan to scale up?
So this is what I spend the majority of my time worrying about right now. You know, you get the customer, and then all of a sudden you have to figure out how to fulfill all those opportunities. I think for me, the two things I really needed to define in my head is what are you actually building? So we talk about scale up, we talk about manufacture. What is the real key milestone you need to get to as a new technology? And I think for us, it was as simple as work back to where you're starting to make EBIT, right? When are you actually starting to make profit? You know, do the techno-economics say, is that at 50 megawatt hours, is that 100 megawatt hours? What is that break-even point? Because then you really defined yourself as a company, and then work back from there. What do you need to do that? And you mentioned ventures, because I think that's somewhat of a realistic hybrid between a licensing model and doing it all yourself, which doing it all yourself for manufacturing, good luck, right? Good luck. So you work back, and we talk about pilot lines as well. I think that's the other point. What do you want your pilot line to do? Because for me, that should be the bare minimum size where you know you can develop continuous IP. So if you are going down a route where you're CapEx light, you own the manufacturing IP. But in itself, it's not that successful. It's not an achievement for the business because it's going to be loss-making. You're going to eat dollars on every cell it produces. So for me, my approach is, yep, you got to build the pilot line. That's a necessary evil. But the real prize is finding the right venture partner who can provide the capital, the infrastructure, and the know-how, and hopefully, especially if you're exporting, those distribution channels that you can lever. And that's the approach we've been taking, right? And so, again, the best case is where you're working with someone with a big enough company that the customer also has a manufacturing arm. Right. And then you really have a closed loop, virtuous circle. Probably easier said than done, right? But I do think it's really important to understand, what do you want to achieve with manufacturing? Because for me, it's profitability, right? Okay. Or at least EBIT. Yeah.
So Arfa, when you're advising your portfolio in terms of scaling up, what would you think?
I guess for us, our job sort of starts and finish at identifying the technology and doing the pilot plant. So manufacturing for us really goes up until almost every new battery technology company has had to build a pilot plant. As we were discussing earlier, just having a powder to sell, it doesn't really work. Just having a solid electrolyte to sell doesn't really work. You really have to build the pilot line. The pilot line is also a way to show the cost reduction path. At least, you'll of course not get down to where you really want to at large-scale manufacturing, but investors need to be convinced that you can actually bring down the costs as you scale up, even if it is just a pilot scale. Yeah. And in order to have that pilot scale facility, you actually need somebody, as Will was saying, to pay for those pilot products and pilot cells. So it is a little bit of a difficult problem to solve, even from an investor perspective. Identifying sites is, we really advise the companies, and I mean, we don't have yet an energy storage technology company in the portfolio, but previously it was about chasing the grants, right? Where the government is providing you land, extremely subsidized land, or providing you equipment, or there is some scheme for labor. If you hire X and X% of local labor, then you can get subsidies on just a lot of the equipment capex or just the land capex, and you get to hire people at a subsidized price, etc. So it's, I don't think as a startup company with just the technology you can really chase or decide where your site is going to be. It is really the grants and the subsidies and financial means that decide for you where it makes sense to actually put a pilot line. Scaling up from that point on, I very much agree with Will. I think the successful startups will have to have a very, very strong product market fit in that your customer really takes up at least half the burden of manufacturing at scale of you, right? If they really want your technology, then they have to participate in helping you scale the production. And I guess the other point is when manufacturing at scale, what we've seen in the European ecosystem at least, it has started with the site, right? It is first the site, then the labor, and then you figure out whatever technology you're going to produce over there. But it's first the government or the regulatory body saying that, okay, I need to localize production. We want this value chain in-house. And then you start talking about technology. So I guess venture investors like ourselves don't really get involved until a lot of it has already been decided.
Right, right. Very good points. I think it's so important to emphasize work with your customer to commercialize, to go to market is important. I remember we invested into a semi-solid state company, and NIO had to send 100 engineers to help them to build up the manufacturing capability and help them really to shorten that go-to-market cycle. We're about to run out of time. I want to really see if there's any questions from the audience that we can ask our panelists to address. If not, I have actually quite a few more questions, but I'll probably just ask one or two. One is really on the fundraising. A lot of exciting technology, but I also think investors, some have been burned by battery investment, and some people can be hesitant. And when you're trying to raise money, do you feel the support from the community, and what do you need to show in order to raise successfully in the marketplace?
So I think that goes back to transparency as well, right? The world has changed dramatically since those who have been burnt on solid-state batteries. We're living in a world where there are way too many dreams being sold and not enough business plans. And so I think being transparent and okay about, hey, this is where our tech's at, going back to, and this is where we're going. It's the same conversation as you have with your customers, right? Because ultimately, it's a marriage, and you're going to need to be able to steward each other towards, are you getting this? Are you on track? Are you not on track? Where do we stand, right? But I do think the second part then is, in this space, again, generalist battery investors, I don't think exists anymore, right? Ultimately, I think behind that has to be a pretty strong thesis on, this is why I'm investing in this space. These are the things I believe in to enable me to invest in this space. And you need to really find someone who's got those compatible core beliefs. And then I think you're having a realistic conversation. If your first chat is describing, what is cycle life, then it's going to be a pretty long process between that and term sheet, I think.
Right.
That's my experience, at least.
Yeah. So for me, raising money is a new thing. I've always worked at large corporates, and money was there and available.
Yeah.
But so I've learned a lot in the last several years. The most important lesson is finding a fit. Depending where you are in the technology, the TRL, the commercialization, what level of risk the investor is able to take. Do they know anything about batteries or cycle life or anything? So a lot of, I'll say, investors want to be educated, but it's not, maybe they want to invest, maybe they don't want to invest, but they always want to be educated. So, I think I've spent, one of my mistakes is I spent too much time educating and not enough time really developing relationships with investors that understand the space, understand the technology, and they're real serious about helping a company develop and advance. And so finding that fit early on is, I think, really important.
Okay. Casper?
Yeah, what I can add is it is not for all investors. It's it takes more time to build a deep tech company. It's risky, and also when you have a customer, they take 3 or 4 years before they go to bring their product to market. So not all investors have appetite for that type of investment, but there is an upside. Yeah. The upside is that, well, first of all, we are addressing real global challenges in this industry. Mm-hmm. We are addressing large markets. And also when we do have the customer relation, it's long-standing relation that, well, not sure if it's really a lock-in, but you have a tight relation, and that can continue for many years. So there are huge benefits, huge upsides, but the investor must have that appetite.
Sure. Arfa, as an investor, what's your view?
I guess at least we are keen to learn, Michael. So I won't take I won't take being educated as that bad of a thing. But I agree with you. I think it is a new space for us as investors. When I was at the previous CVC, I was working at battery technology was a new thing. We were just about starting a renewables business, let alone batteries. And now we are still trying to figure out, one of the things investors do is go by historic performance of a sector. for renewables in general, there's not much benchmark to pit against. Batteries are even more advanced, solid-state batteries even more advanced. So when you don't have anything to look back on, I think that that is really why education and educating the investors, and I'd really like to thank all the founders, not just on the panel, but also in the audience that are doing the work. I feel like as a physicist by background, I take it as a job to actually educate not just my team and our stakeholders, but other investors. Whenever I sit and chat with them, I'm going to do a lot of that at ETS, make sure I have coffees with people just to tell them about, hey, this is what solid-state batteries are, and this is what second-life batteries are, and this is how batteries are made, and it's really nothing to be worried about or scared of. But as investors, a few things that we discussed today. Manufacturing, yes, as Casper is saying, you really need to know the kind of risk appetite your investors are going around with. Yep. There are investors that just want to invest in a manufacturing site. So if you have de-risked the technology, you have a good product market fit, you have customer offtake, there are investors that are willing to take that risk on just manufacturing. But if you go to investors and say, hey, my technology is just about working, this customer might just pay me half the price of what I'm building, and there are these two guys sitting somewhere in South America that I want to hire in Europe, I think I can make it work, and that's not going to fly. So it's a little bit about, putting one or two variables that your investor can digest instead of saying, okay, there are 5 and all of them are variables and they will change. Nothing that we can guarantee you. That makes it a little bit difficult for us as investors. But hey, just to end on a positive note, it's not all doom and gloom. We are a small fund. We do growth investments and we do look at energy storage. Yep. We like technology companies. We want to find ways around the challenges we have. We are trying to build partnerships between startups and customers and manufacturers. Hopefully you and I can have a bit of a chat and try to take some European companies to manufacture at scale, be it in China or America or wherever. But I think the finance industry is warming up. They're hiring PhDs like me, at least, to say that they're not afraid of technology anymore, right? They want to learn, be it from the founders or be it from others in the industry. So hopefully 5 years down the line, we have a different conversation, right? It's more the founders deciding who they want as investors than the investors deciding which companies they want to invest in.
That's fantastic. And on this panel, I'm learning a lot from really the promise of the cutting edge development in the solid state and also in Casper material space as well. And the two investors on the panel are both interested in investing in this space. So that's definitely, to your point, I think there's promise in developing this advanced technology to go to market. And with that, please join me in thanking the panelists for sharing their insights. Much appreciated.
Thank you.